So you're hungry and you're making a delicious Hot Pocket as an after-school snack. You microwave it, eager for the savory wonder calories about to enter your mouth, and you don't let it cool. You bite into your Hot Pocket and, ow, you burn your tongue. What's going on here? Why is your body being so miserably cruel? You just wanted a Hot Pocket after all. Okay, so you just bit into your Hot Pocket and the microwave heat has sent your sensory neurons into action. That neuron now has this important information for your brain. This is hot. And your brain will soon send back a message that says, don't put the hot thing in your mouth again until it's cool. But how does the hot message get from your tongue to your brain and back again? Neurons pass the information from one to the next down a nerve strand in the form of electrical impulses. The net electrical charge of the molecules inside a neuron is more negative than the net charge outside the cell. That difference is called the membrane potential. In order to maintain its internal negativity, neurons have protein channels called sodium-potassium pumps. The pump lets out 3 positively charged sodium ions, Na+, for every 2 positively charged potassium ions it lets in, K+. Think of it like this. If I, the neuron, gave you $3 for every 2 you gave me, I would have far less money at the end of our transaction if we started with the same amount. So, when the neuron becomes active and transmits an electrical signal, it changes the membrane potential within the cell to create an action potential. There's another protein in the neuron's membrane called a sodium channel. The sodium channel is voltage-gated, meaning it only opens to sodium when the charge around it gets positive. At the beginning of an action potential, a neurotransmitter chemical stimulates a sodium channel to open, and that allows Na+ to rush into the cell with a concentration gradient. Remember, it's super negative in there. The influx of Na+ changes the charge in the area around it, making it more positive. That positivity forces more sodium channels to open further down the axon. These in turn allow in more Na+, which makes their areas of the neuron super positive. Charged particles in the neuron are not actually moving down the neuron, but, like doing the wave at a baseball stadium, each person standing up makes another person stand. So if you look at the general effect, it's as if a wave were passing through the people, but no people are really moving. When the wave of the electrical impulse created by the action potential reaches the axon terminals, the neuron creates more neurotransmitters, chemicals that pass the information provided by the wave on down to the dendrites of the next neuron in the chain, which starts the electrical process all over again. The body uses the natural electrical charges of molecules within to create a kind of wiring similar to the wire used in electrical cords. Now, you may have heard of a disease called multiple sclerosis. Multiple sclerosis, or MS, is a serious condition that affects patients' vision, coordination, strength, sensation, memory, and thinking. MS happens when the immune system turns upon the body and destroys the myelin sheath that's so important to the function of the neuron. This affects the functionality of the neuron and causes symptoms around the body. In other words, it really, really sucks. So be thankful for your myelin sheath, and for all your neurons, because they help you eat Hot Pockets and do everything else. Gotta love that action potential.